Okay, this video is on simplifying square roots. Now, if you are given a square root of a number that is a perfect square, then it's easy to simplify that. The square root of 4 is just 2, and we know that because 2 times 2 is 4. Or the square root of 36 is 6, because 6 times 6 is 36. But what if you were asked to find the square root of 75? We don't want a decimal form, and if you put it in your calculator, that's what your calculator is going to tell you. If you put 75 and you hit the square root button, you see we have a decimal. And we do not want that, and we want to be able to simplify this to simplest radical form. And so in order to do that, we are looking to see if 75 has any factors that are perfect squares. So in other words, if any of these perfect squares divide evenly into 75, then that means this will simplify. And we will actually want to find the largest one that we can, because sometimes there's more than one. So I always start from down here, and I'm looking for a number that will divide evenly into 75. And you can use your calculator for this if you want to, but many of you will recognize 25 as a number that divides evenly into 75. And 25 goes into 75 3 times. So we're going to break 75 down to 25 times 3. Now, I always write my perfect square first when I write those factors. The square root of 25 then is 5. So we've taken the square root of this number, so that number comes out from under the square root. That's a 5. We don't know the square root of 3, so that will stay underneath. And this is the square root of 5 in simplest form. All right, let's try another one. What if we have the square root of 45? Again, we're looking down our list of perfect squares. We're looking for the largest number on our list that divides evenly into 45. Okay, none of these are going to work. I think the largest number that'll go into 45 on our list is 9, and it goes 5 times. So I'm going to break this down to 9 times 5, and then I'm going to take the square root of 9, which is 3. That'll be on the outside now, and I'm going to have the square root of 5 left over. All right, square root of 32. Now this is a good example of why you want to start from the bigger numbers, because a lot of us will right away recognize that 4 goes into 32. But that's not the largest perfect square that will go into 32. So let's come from this way, and you can see 32 divided by 16 is 2. So 16 goes into 32 2 times. Now we want to use the largest one, because if we don't, it won't be simplified all the way. It's kind of like reducing a fraction and not picking the greatest common factor to divide the numbers by, and then you have to reduce the fraction again. I'll show you what would happen if we had used 4 in just a minute. All right, so we use 16. 16 goes into 32 2 times. The square root of 16 is 4, and then we have the square root of 2 left over. Now, out here I'll show you what would have happened if we had picked 4, sorry. 4 goes into 32 8 times. All right, then we would have gotten 2 square roots of 8. Now, this has been simplified, but it's not in simplest form. And the reason I know that is because 8 has another perfect square that'll go into it, 4. So this could be simplified again by breaking the 8 down to 4 times 2, then taking the square root of 4, which would bring another 2 to the outside, and this 2 is left underneath, and we would end up with 4 square roots of 2, which we got here. The problem with doing it this way is a lot of people do this first step and they think they're finished and they stop there, and it's not simplified all the way. As long as you realize that 8 can be simplified again, then this way is fine. But it's going to be faster if you pick the largest perfect square that will go into the number. All right, let's see. How about the square root of 162? Now that one's a little bit tougher. Let's see. I'm going to use my calculator. I know 100 won't go into it evenly. What about 81? It does. It goes 2 times. And so 81 is going to be the largest perfect square that divides evenly into 162. 81 times 2. The square root of 81 is 9. We don't know the square root of 2, so it stays underneath the square root. Alright, so 9 square roots of 2. Here's another one, 108. Again, start from the big numbers. Alright, whoops, I got a 2 on there. 108 divided by 64. No. 108 divided by 49. No. 108 divided by 36. Yes, 36 goes 3 times. So we can break that down to 36 times 3, and we get 6 square roots of 3. Alright, now what if we add some variables into the mix? What if we have the square root of m to the 7th? Now, we talked about in a previous video about how any variable raised to an even power is going to be a perfect square. And so what we want to do, this is an odd power, but we want the highest even number that's less than 7 will be a perfect square. So 6, m to the 6th is a perfect square. So I'm going to break m to the 7th down to m to the 6th times m. Okay, that makes 7. 6 plus this understood 1 is 7. And I know any variable raised to an even power is a perfect square. So the square root of m to the 6th is m to the 3rd. And then we would have this m left over. So m to the 3rd square root of m. Alright, let's try another one like that. What if we have x to the 3rd, y to the 5th? Again, these are odd powers. Those are not perfect squares. But the highest even number that's less than these is a perfect square. So I'm going to break the x's down and the y's down. X cubed, I'm going to break it down to x squared times x, because 2 is the biggest even number that's less than 3. So I know that's a perfect square, and we'll have 1 left over. And then y to the 5th, we'll break it down to y to the 4th times y. 4 is a perfect, y to the 4th is a perfect square with 1 left over. Alright, now let's take the square root of what we can. The square root of x squared is x. The square root of y to the 4th is y squared. And then left underneath we'll have an x and a y. Okay, now let's do one with letters and numbers in it. How about 48x to the 5th? Alright, so we've got to look at the 48, and we've got to break it down, and we've got to look at the x to the 5th and break it down. So 48, we're looking for the largest perfect square that'll go into 48. Let's try 16. Yes, 16 goes 3 times. So I'm going to go ahead and break my 48 down to 16 times 3. Now x to the 5th, the largest perfect square, less than x to the 5th is x to the 4th, which will leave 1 left over. Alright, now this is a perfect square and this is a perfect square. So those two we're going to take the square root of. Square root of 16 is 4. Square root of x to the 4th is x squared. What's left over underneath? 3x. Alright, now what if there is already a number outside the square root? Like this, 5 square roots of 20. Alright, we need to simplify what's under the square root. So let's go ahead and look at the 20. We're looking for the largest perfect square that'll go into 20. I believe it's going to be 4. Now keep this 5 on the outside. We'll break the 20 down to 4 times 5. The square root of 4 is 2. So that 2 is going to come to the outside and this 5 is going to stay underneath. When this 2 comes to the outside, we need to multiply it by the 5 that's already out there to get 10 square roots of 5. All right, let's try another one like that. How about 2 square roots of 147? Okay, I have no idea what goes into 147, but we're going to find out. All right, not this, not this, not this. 147 divided by 81. No. 147. Now, if this is an odd number, no even number is going to divide into it evenly. So I don't have to try 64. I'm going to jump on down and try 49. And 49 does go in 3 times. All right, so I'm going to break 147 down to 49 times 3. The square root of 49 is 7. So a 7 is coming to the outside of the square root. We're going to leave the 3 underneath because we don't know the square root of 3. The 7 gets multiplied by the 2 that was already out there, and we get 14 square roots of 3. All right, let's try one with a little bit of a bigger number. How about 120, the square root of 120, a to the 7th. All right, so 120, we're looking over here. We're looking for the biggest perfect square that'll go into 120. I don't know if 36 will or not. Let's see. Clear. I don't think so. Nope. How about, let's try 16 and just make sure it doesn't. No, that was close. I don't think 9 will. 120 divided by 4, is that going to be the biggest one? I think it is. All right, so 120 will break down to 4 times 30. A to the 7th, the largest even power less than 7 is 6. That will be the perfect square, a to the 6th, with 1 left over. So we've got a perfect square here and here that we can take the square root of. That's going to be 2a to the 3rd. And then left under the square root, we've got 30a. All right, let's see. What if we have, we're going to try one more, 7a squared, square root of 28ab cubed. All right, let's look at what's under the square root and try to break it down as much as possible. 28, we're looking for the largest perfect square that will go into 28. I believe it's going to be 4. Now I'm just going to leave my 7a squared here on the outside. Under my square root, I'm going to break that 28 down to 4 times 7. A is a to the 1st. There's no perfect square I can get out of that. B cubed, let's see, b squared would be the largest even power, less than 3, and that would leave 1 left over. So I've got a 4 I can take the square root of, and a b squared I can take the square root of. So the square root of 4 is 2, and the square root of b squared is b. And then let's write what's left over. We've got 7ab left underneath. Let's multiply this together. So we get 14a squared b on the outside and 7ab underneath the square root.